x squared plus 5x minus 14 over x squared minus 4. Now, here's what I want you to do for me. I want you to treat this as if you are going to graph it, okay? If you were going to graph it, what would be your first step? You would want to factor it, okay? So factor it for me, please. Okay, what did you factor the numerator into? X plus 7, x minus 2. What did you factor the denominator into? What do we call that denominator? What's that? What? Difference of, okay, right? So here it is popping up again, right? This is so important for you guys. And you probably want to have your factoring chart handy when you work on these types of things, because we'll be doing a lot of factoring. So now then, my next question to you is, if we were going to graph this, would it have a hole?
Yep.
Yes. So that means we have a common factor that we can cancel out. Which one is it? Well, the whole thing is x minus 2. Okay. So we'll cancel that. And then let's rewrite what we have left over. In the numerator, we have left over the x plus 7. And in the denominator, we have left over an x plus 2. Now, the next thing I want you to do for me is I want you to put those two binomials in parentheses. Okay? And the reason why I want you to do this is because if you had left this as x plus 7 over an x plus 2, and if I asked you, could we simplify anything else, what would you tell me? Yeah? What would you cancel? You would cancel the x. But here's the deal. That's not just an x in the numerator. It's attached to the 7. That's really an x plus 7. And in the denominator, that is not just an x. It is an x plus 2.
You can't do anything.
So you can't. You cannot cancel those and say that you have a 7, 2. You cannot do that. Okay? So I want you to put the parentheses around them so that will keep you from doing that. Okay? Because that's a really, really big mistake that a lot of students make. And when you're looking at it with parentheses, you can see that, in fact, they are a pair and they go together, and you cannot split them up. And this, from here on out, you need to remember that, because we'll be doing a lot of factoring and a lot of canceling. Okay? All right. Yes. Now we have two separate rational expressions, and you see in the middle we have the multiplication. So what we're going to do is we're going to multiply these together. So you have a 2x squared minus 8 over an x squared minus 1. And you're going to multiply that with an x squared plus a 2x plus a 1 over your x cubed minus your x squared minus your 2x. Now, this is really what multiplication boils down to when you're working with rationals. You're going to treat the denominators. You have two numerators. You're going to treat those separately, and you have two denominators, and you're going to treat those separately. So this is just basically taking four separate expressions and factor them. Okay, so that's the next thing I want you to do for me. So I want you to treat them all separately, and I want you to factor them.
So basically, we get four equations, the two that go on top, we combine them, the two that go on the bottom.
Yes, yes.
So it's a factor each one.
All right, the 2x squared minus 8. What's the first thing we do to that one? That is a greatest common factor of 2. That leaves you with x squared minus 4. And what's an x squared minus 4?
The difference of 2.
Difference of 2 squares. So that would be x
minus 2.
X plus 2, x minus 2.
Yeah, x plus 2, x minus 2. Thank you. What about the denominator of this one? Of the x squared minus 1, that is also a what? Difference of 2 squares. So how would we factor that? Now, we're going to move over to our second one, the x squared plus 2x plus 1. What was that factored into?
X plus 1.
Yes. My suggestion to you guys on this is don't do the x plus 1 squared. List them so you can see what can be factored out. The denominator, the x cubed minus the x squared minus the 2x. What do we need to do here?
Pull out the x.
X, greatest common factor. So that would leave us with x squared minus x minus 2. And then that would be factored. Bring down your x. And then what were you able to factor that one into?
X minus 2, x plus 1.
Okay. Now, we've gotten all the factoring taken care of. Now, here's our next step. We're going to cancel any common factors that we have. You can cancel, as long as you cancel one in the numerator and one in the denominator, you can cancel, like, if I have something over here in my first one, but it matches with the denominator in my second one, that is okay. So, like, look at your first one. You have an x minus 2. Let's change colors so you can see it. X minus 2 up here, but look, what happened to my 1? Is that right? Okay. That will make a difference. So if I have an x minus 2 here, but I go over here to my second one and I have that in the denominator, I can do that. I can do it because everything is straight multiplication, so we can cancel out. What else do you see? X plus 1 will cancel this x plus 1.
We can't cancel the ones next to it.
You cannot cancel both of them. It's a 1-to-1. It's like your matching game. You can only match 1 to 1. What else do you see?
Another x plus 1.
Another x plus 1. So there you can cancel those two as well. It's a 1-to-1 match.
So what would you be
X minus 2.
So is that all we can cancel?
Yes.
Now we're just going to bring everything over and we're going to combine it into one final rational expression. So in the numerator we have left over in your first one, you see you have left that 2 and times the x plus 2. And in the denominator you see that in your first one you have an x minus 1. And then you also in your second one have an x. That was that greatest common factor. Always put your greatest common factors in front or before you list your binomials. Okay? And so that would be your simplified,
from a whole that we go from.
and that would be your answer.
What are the restrictions on
How
x?
did both of the x plus ones get crossed out?
Because I had an x plus 1 here that canceled with that one, and then I had this one cancel with that one. I had a 1-to-1 cancellation on both of those. Okay, so now let's talk about the restrictions. Identify any restrictions on your x. The restrictions are going to be what values of x would make this undefined. So you're going to come back to all the things you had here. What values of x would make this undefined?
-1,
-1 here.
2.
So basically the ones that we cancel.
All of them.
So we,
Canceled or not. Canceled or not. You don't take into
also all of those x's.
all of these before you cancel. What values of x would make this undefined? So here that would be a -1.
Basically all of the things in parentheses, like if there was no difference, we just set them all to 0.
So the x minus 1 would go to 0 when it equals positive. This x would go to 0 when x is
Finding all the
0. This would go to 0 when x is positive 2.
Miss, how you get zero?
And this would go to 0 when x is -1, which we have already captured right here. So these are the restrictions. These are the restrictions.
So the ones you don't cancel out are positive.
Yeah, but it doesn't matter if you cancel them out or not. You still include them. So
basically
you
all-
could do this. You could actually do this before you cancel.
So what about the x plus 2? Would that mean x not equal -2?
Yes.
You're turning all of them into zero.
Did we miss that? Yeah, we got that
That's why you
one.
get a negative.
No, the x plus 2 up there.
Next to the
Numerator. So this one you were left with, I'm going to kind of do one little extra step. Well, after you canceled out, you were left with a 2. You were left with a 2 up here times, what was x minus 10, was it? And then down here you were left with the 4 times the x minus 5 and the x minus 2. And then I went back around and showed you that you will treat those as a fraction, which would reduce down to a 1/2. And our restrictions were X cannot be what? Negative 5, positive 5, negative 2, and positive 2. And there's your
Is
restrictions.
that only in the denominator?
Yeah, only denominator. So you got what? Tell me again. You got
Plus 3, x plus 2.
x plus 3, x plus 2. What'd you get for the x squared minus 4?
X minus 2, x plus 2.
Okay. Now, what'd we get for the 5x plus 15?
5 parentheses, x plus 3.
And what'd you get for your denominator?
X minus 2 times x plus 2 thirds.
3x minus 2. One of these has to be a positive.
X plus 2 is x plus 2.
Yeah.
Wait, for your why isn't it plus 2?
Okay, so we have 3x minus 2 and the 3x plus 2. Is that correct now? Okay. So now give me the restrict.
How is it 3x plus 2?
Yeah, how is it 3?
If you multiply this out, what you need a negative 4 back in the middle. So x times 2 would be 2x. Negative 2 times 3x would be negative 6. So negative 6 plus 2 would be negative 4. You should have done that when you were doing your x method.
Because,
Okay, so give me the restrictions.
Negative 2,
let me, I'm trying to figure out how would you get that from?
positive 2.
X cannot equal negative 2.
That's
Go ahead.
it.
I don't understand.
One more.
2, negative 2 thirds.
What about your 3x plus 2?
X cannot equal negative 6.
Negative 2 thirds.
Negative 2 thirds. Okay. Now you're going to flip it. So now you're going to flip it. So let's bring that over. So now you're going to leave your first term exactly as is. And then change it to multiplication and then do your flip. So now that 5 times x plus 3 will drop to the denominator. And the x minus 2, 3x plus 2 will be in the numerator. Okay, tell me what you canceled.
X plus 3,
X plus 3s go.
x minus 2s,
X minus 2s go.
x plus 2s.
And the x plus 2s go. Okay? So that leaves you with what in the numerator?
3x plus 2.
And what does that leave you with in the denominator?
5.
Uh-huh. Yeah, we did.